Hi everyone, today we are talking an important health topic that affects many people around the world, that is PCOS, Polycystic Ovary Syndrome. It's a condition that many women experience and it can cause problems like irregular periods, weight gain and other health concerns. If we detect it early, it becomes much easier to manage and treat. That's why for our project we decided to focus on finding a solution using technology. We have machine learning, which is a type of artificial intelligence, to build a system that can help in identifying early signs of PCOS. In this video, we will take you through our journey, why we chose the topic, how we collected and prepared the data, the methods we used to make the system smarter, and the results we got. Our goal was to make the diagnosis process simpler and more accurate.
Problem statement. Polycystic ovary syndrome is a common hormonal condition affecting women to reproductive age, which can lead to serious health disorders if not diagnosed and treated on time. Many women may not realize they have PCOS. Traditional diagnostic methods are often slow, requiring multiple visits to healthcare providers. Therefore, there is a need for a faster, automated system that can quickly analyze health data with accuracy, provide users with immediate feedback on their chances of having PCOS. The primary objective is to develop an efficient and accurate machine learning based system for the early detection and diagnosis of polycystic ovary syndrome. It improves diagnostic accuracy, enhancing accessibility, ensuring scalability and real world application. Proposed plan. Data collection and pre-processing. Collect the relevant datasets, clean and standardize the data, and identify essential features to train the model accurately. Model development. Implement machine learning techniques such as decision trees, SVM, or neural networks. Testing. Divide the data into training validation and testing sets. Refine the model and access their performance using important metrics. Deployment. Incorporate the most effective model into user-friendly interface, track its real-world performance, and make improvements based on user feedbacks.
For detection of PCOS, we are using Aiml techniques. First, we are loading the dataset, which is comma separated values, and printing the data. The dataset contains various columns with different names like number, PCOS, age, BMI. We are use we are using visualization and learning modules. For visualization, we are importing matplotlib, seaborn, and pandas. For training the model, we are using sklearn, and we are also importing logistic regression random forest decision tree from sklearn. After that, we are checking whether our dataset is containing any duplicate and null values or not. It shows that our dataset does not contain any duplicate values or null values. Now we are changing the PCOS column name to target, and we are further plotting the graph between target and other columns. This helps us to understand better, for example, which feature is affecting PCOS can be analyzed in a better way. Now we are plotting a heat map. This helps us to identify the combination of one feature with other, and it also gives the probability of one feature with other feature. For example, target and fossil number right having a probability of 0.65. Target and fossil number left are having a probability of 0.6. And these are the graphs which are plotted against target and the column name. The people in between 25 and 35 are having a chance of getting PCOS when other symptoms are tested positive. Now we are changing the dataset by considering the upper and lower limit of age, and we are sorting the data in an ascending order. We are printing the top 5 values in after sorting. We are training the model by using logistic regression, decision tree, random forest, And further, we are plotting a graph between the accuracy of each model. Random forest is showing highest accuracy, that is 87%. We are using random forest for prediction of the disease. We are giving the new data for the model in order to check the performance of the model. It shows the new data does not have PCOS. We can also take the inputs from the user and predict whether the person is having PCOS or not.
So this is the code for the web approach of PCOS detection using machine learning. These are the functions that need to be imported from the Python. This is the warning line whenever this instance app is equal to flask name. This creates the flask application which runs when program file is run, and then this template folder template, this is the folder where the HTML files, root files are saved. When accessed, it comes. This is the model path, and this code is to trigger when the model file is not found. These are the HTML files, and this is the URL for accessing the HTML file. This predict function predicts the output whether PCOS is detected or not by getting the values from the form detect HTML file. Then it returns the possibility of PCOS. If prediction is 1, possibility of PCOS, yes, no PCOS, then it prints the message on the screen. This part of codes run when debug equal to true. So now we will run and see. This is the web approach. This is the home page, and here there are self diagnosis, diet plan, and exercise plan. Now when we go to self diagnosis, by clicking on self diagnosis, PCOS detection page is open. Here enter the medical values, the values which need to be entered, and after entering the values, let me complete it. And it can take float values also. So the values which we entered resulted in the possibility of PCOS. So there is the possibility of PCOS. Next, when we go back to home page, there is a diet plan, and there is a exercise plan which are can be used to further prevent of the PCOS or reduce the effect of PCOS on our body by taking proper diet plan and exercise plans. So this is the web approach. In future, it can be improved by adding gyno help and advanced algorithms, and it can help in assist chatbots and all.
Future scopes of our project: advanced models using CNN and LSTM for improving diagnostic accuracy, time series moderating, analyzing the system trending for better disease tracks, variability integrating, incorporating real-time data from healthy devices for detailing insight, cross-validation, training with data sets for greatest accuracy and generalizability. User-free apps. Developing an app for the systems tracking personal influence, visibility, healthy trends. Conclusion. This project showing how the machine learning can help in healthy care, especially with declaring the PCOS, Polycystic Ovary Syndrome, by carefully cleaning, analyzing the data, picking the right feature, and using the best machine learning models. It solves the challenge and make early diagnostic and management of PCOS more effectively.